Um, he's going to give us a very exciting talk on Gentext to Gen Discovery. And a little bit about IIT Agni and what we do. IIT Agni is an association of IIT alums in New England. And if you want to learn more about what we do and subscribe to our social media, I am going to post the link in the chat for you to have a look. All right, I think it is 3 after, so let's at least get the introductions rolling. That will give us more time for Vinayak's talk as well as questions. We're looking forward to a very lively discussion today along with the talk. So let's get going. Yeah, I would like to welcome everybody who's here, and it is my honor to introduce Vinayak, who is a senior lead engineer at BioState AI, where he's working on developing cutting-edge systems that enable scientists to use AI for research. And he has earned his undergraduate and master's degree from IIT Bombay, batch of 2018. And he completed his PhD at MIT, where he focused on working on auditory perception and cognition-inspired engineering. Outside of his work, Vinayak is a semi-professional Mohan Veena player, and I have heard him play. He's amazing. So it's wonderful to have you here, Vinayak. Why don't you tell us a little bit about what your talk is going to be about, and then we can get started. Okay, but before we move on to the talk, I do have another little plug as well. We at IIT Agni have been doing these generative AI events over the past few months, and we're trying to keep that up. And we have another event coming up next month. Shrikant, who's also here in the call and is going to be helping us moderate the chat. So one of our friends, we're going to be organizing a vibe coding workshop coming up in December. We will be sending out the registration details soon in the newsletter, as well as our social media. I have pasted a link in the chat for you to join our WhatsApp group and our social media. So if you're interested, please follow us there, and then we can keep you posted. Yeah, and with that, Vinayak, the floor is all yours.
Thank you. Thanks a lot, Richa, for the generous introduction. Yeah, it's really good to be talking to you guys today. I've spent about 6.5 years in Boston. I'm in California right now, which is why we're having this over Zoom. I'm excited to share what I have. So just a little bit about what we'll be talking about. So there's this AI scientist called Cadence that I was leading the development for within BioState, which has been now spun out as its own company. I'll be talking about that as well. Basically, I'll be talking about agentic AI scientists in general. First of all, what makes a scientist, and how can we make agentic AI autonomous scientist? A little bit about myself, just to show you how I ended up doing all of this. So I was doing mechanical engineering at IIT Bombay, sort of focused around acoustics and automation. My specific specialization was computer-aided design and automation. It was used to be a dual degree program at IIT Bombay back then, which no longer exists. I think they did away with dual degree programs at IIT Bombay. But After I did that, I did a bunch of acoustics research at different places while I was there, and after that at MIT as well for the first year. And then I moved into computational cognitive science. So that was sort of my bridge between, you can say, my acoustics background and what I have been doing since in artificial intelligence, because I was really intrigued by how the how nature, and more specifically human brain, solves the problems that as engineers we try to solve, but we're not able to optimally solve for. For example, when something falls in a kitchen, in an instant we can tell, oh, it's probably a spoon. It fell, it didn't break, and it's in the kitchen, it's not in the living room. It takes us an instant just with two microphones to do this. I used to be doing underwater remote sensing. We used to have 100 microphones underwater and still had no idea what was happening under the water. So that actually intrigued me a lot. Actually, this is one thing that I really wish the IIT ecosystem actually worked more on, which is like cognitive science. Basically, not psychology as a humanities subject, but more as a science which has computational principles underlying this, because I feel in India we didn't get much exposure to that side of sciences. It was either you do computer science or AI, or you do psychology and humanities. There's like very little overlap. Hopefully that is improving now. Um, and then I've been working in artificial intelligence ever since ChatGPT came about, actually, because I was at Meta doing an internship on AR and VR, and that's actually when ChatGPT dropped. And ChatGPT, although had its issues, but since I had been in the space for a while, I was actually really intrigued because I knew that these capabilities exist, but the world knew for the first time, and that basically was an indication that there is widespread interest, and now development will take place like at a very fast pace, and it has been. So you know how wild of a ride it has been from 2022 to now, where like every day something new comes up, the whole tech stack changes. A new model comes out. Whatever we thought was an issue with generative AI suddenly is no longer an issue anymore. Yeah, it's just wild. Like just to give you an example, Josh Tannenbaum, who was also one of my collaborators and a very good, I think, a very famous professor at MIT. He once said that like AI cannot think like humans because as a human, you can imagine a blue monkey eating a red banana, but AI cannot. And this was in 2020. But in 2022 or 2023, DALI came out, and DALI could actually imagine a blue monkey eating a red banana. So that was pretty interesting to me, seeing like how criticisms actually led to more developments, and like that's why this um, like going from cognitive science to AI, I feel was a very natural transition. So just to talk about what I do currently, so I was the lead AI researcher at BioState AI, as Richa said, but actually very recently, just last week, we spun out a new company on the this autonomous science initiative within the company, and now we spun out this company called Cadence that is focused solely on building the AI scientists. Like we are still within the BioState umbrella because like we were 4 or 5 people within BioState AI who sort of did this, and like BioState decided that we should be our own company because like BioState also does other things like foundation models in biology. So that's where I am right now. Just to go over what I'll talk about. So first we'll talk about what generative AI is and what agentic AI is, just to make sure that we're on the same page, because these things can mean very different things for to different people. Um, so yeah, just to clarify that. Then how we enable autonomous discovery with Cadence with some examples. One specific example that I'll go slightly deeper into is longevity research we did with David Sinclair at Harvard. Um, and then at the end, I'll talk about the path forward, what we are doing, what we can do. I would love to know more about what other people are doing in this field if they're in audience. Um, and yeah, we'll take the discussion from there. Please interrupt me wherever, ask me questions. That will give me very good feedback on what you want more information over, what I should just skim over, and that will help pace the talk as well. So let's dive into it then. Let's just go into, first of all, what generative AI is. So very simply speaking, it's just AI systems that create new content, right? Um, a lot of times nowadays, it refers mostly to LLMs, but it could be diffusion models, it could be like text to image models, it could be any AI model, any computational model that generates content. And foundation models that are trained on massive data are a type of generative AI that have taken over the field so much that they have become synonymous with generative AI in some sense. Because a lot of generative AI that we keep seeing around us is actually based on foundation models or are foundation models themselves. Then what's agentic AI? It's basically multiple specialized AI modules that communicate together to accomplish tasks that are typically difficult for a singular AI entity. So, in other words, you can also say it's like AI with agency. That means if you have an AI model or a set of AI models that have the ability to take action, talk to other AI modules, etc. So let's talk about that moment. Like when ChatGPT hit in 2022, I was still in grad school. I was doing scientific research full time. I was usually in this space already. I could see its strengths, but for science, I could also see its weaknesses at that point of time, right? So if you guys remember, it was really good at natural language understanding. Like you put in an email there, it was very good at telling you this email, like it could rephrase an email for you. It was very good at mimicking writing styles. You give it a write up of your own, it can like continue in the same style, or you can say write a poem uh, like William Wordsworth, and then it would actually do it. And so it was actually pretty good at those kind of things. It would be garbage, but it would be very good looking garbage. So it was really exciting from a person who did computational sciences that like we were able to do even that much. Obviously, there was a lot of criticism because it was not perfect. But for people in the space, they knew that we've come a long way to be able to do that. It was able to generate good code syntax. It wasn't able to like code within your environment yet. It wasn't able to, but it was able to help a person like me who knew what to write but didn't have the words. So actually, I don't know, there might be more people from MATLAB here. So I was a very avid MATLAB user. Um, and I was afraid of, say, doing JavaScript or TypeScript. So if I had to run online experiments, I was like, I don't know how I'll do that because I have to write JavaScript code to actually make a website. But ChatGPT, even when it hit, I was like so happy because even if it gave me code that didn't work, it actually gave me the pieces that could convert my thinking in MATLAB to JavaScript. So it was actually a very big strength. But the limitations were obviously the biggest one. It was a hallucinating monster. Uh, Anything important, you couldn't have trusted it. It would like say things that look correct but were absolutely wrong. And like there was no expectation of it being right as well. Like neither did OpenAI claim that it was going to say right things, nor did we find that it says the right thing. Sometimes it did, but there was no reason for it to. There was no iterative reasoning, so there was some amount of shallowness where like it would say something, but if you actually at that point of time I had figured out that if you pipe its response back to it, it sometimes keeps improving, but there was no like automatic way for it to keep improving its response. It was like a child who would not think before saying, just says something and doesn't realize that what they said doesn't make sense. Until unless you tell them, well, did this make sense? Please actually look at this again. Uh, Another major limitation was that there were no real world actions. So it was just text in, text out. There was nothing more you could have done with it. One thing that some people had figured out back then was that although it's text in, text out, but if the text out is, say, code that can do stuff, then also you can give some actions. But again, hallucinating monster, you don't want it to take random actions. So there weren't any actions you could have taken at that point. And the main thing for scientists was that there was a trust issue for anything important. You could not have trusted it with, say, scientific writing. So citations won't be correct. Maybe the claims it's making should be correct in a parallel universe, but aren't correct in our current scientific knowledge. And these kind of things would happen. So there was no trust. Even if it was right, it started being right after GPT-4, 90% of the times. Still, that 10% was a good enough reason to not trust it, even if you use it for something. So all in all, it was good at spitting good looking garbage, right? So it was like it looked really nice, but nobody knew how to use it effectively other than just writing emails or doing like some basic literary work that depended on natural language understanding. So to actually address each of these issues, there was a lot of work done in the field. So for the shallowness, they were thinking models that were able to actually pipe their own responses within themselves. They were able to reflect on their responses. They were able to plan out outputs and then basically using the large context, think about whether they're going in the right direction or not, and do multiple passes before actually coming up with an answer. And also uh, having multiple AI agents. So the agentic AI bit that I explained earlier, having multiple AI models talk to each other also helped uh, get around shallowness, because you can have specialized versions of these LLMs or other generative AI models that would like talk to each other. So they were specialized in their own way. So together they were not shallow anymore. They had depth in some shape or form. For hallucinations, we got RAG, or retrieval augmented generation. So people figured out, wait, what if we just do a Google search and give that whole Google search to the AI agent and make sure that it only gets information from that Google search? Like, sounds theoretically something that should be done. Doing that correctly obviously involved a lot of CS work. If you guys have heard about Perplexity, so Perplexity was also one of the first companies to sort of spearhead this. He's also a IIT alum. I think some of you might actually know. I'm forgetting what his name is. Srinivas? Okay. Okay.
Yeah.
Yeah. So then the lack of real world actions, there was tool support and a new thing called Model Context Protocol, which is also known as MCP, which is right now taking the Gen AI world by storm. Everybody just creating MCPs for everything. And that's also because actually there's another block that's not here, which is privacy, because a lot of people had big issues with privacy. They're like, how do I put my proprietary data into these models without actually like sacrificing the, the control of the data? And even today, actually, people have that issue, and it's good to have that issue because there's no clear answer of what you should do or what you shouldn't do or how these models respect privacy or not. But the good thing with MCPs, or model context protocols, is that any execution or any data lookups happen on the client side, in this case, wherever you want to maintain privacy, and that just gives out information to the LLM, which is privacy preserving, but enough for the LLM to act on it. So there are many things with MCPs that maybe we can go into later if we have time. But like that was tools, and MCPs actually gave hands to these models. They were able to book tickets for you. They were able to look up information for you. They were able to execute code, look at the code's output, and like that's what sort of spearheaded the whole vibe coding revolution as well. Like once these models got tools. So with this, actually, I would like to move to the next part of the talk, which is AI for scientific discovery. But till this point, um, like, do we have any questions on what agentic AI is, what generative AI is, etc.? Okay, so let's go to AI for scientific discovery then. So AI has been taking over scientific discovery even before generative AI became a thing, right? You guys know 2024 Nobel Prize for Physics was actually given to two AI scientists, or machine learning scientists in some sense, John Hopfield and Jeffrey Hinton, for their contributions to artificial neural networks, which was a very big deal because this was the first time anything related to computer sciences or computational sciences was recognized at the highest level in science, where instead of just giving them a Fields Medal for contributions to math, their contributions to physical sciences or basic sciences were recognized. Similarly, with AlphaFold, which I would say is actually the first truly autonomous discovery thing that blew up, where which discovers like new interaction patterns and structures for protein molecules, where actually the first author had no strong background in chemistry or biology, was a computer scientist, but actually got a Nobel Prize for medicine because of what their AI enabled, which is also a deeper question philosophically, um, of whether um, like AlphaFold should have gotten that Nobel Prize, or whether the makers of AlphaFold should get that Nobel Prize, because the scientific discovery would actually happen through AlphaFold instead of through the author. Well, I have a very hot take on that, but it was really nice to see AI actually taking over scientific discovery in a way where like basic sciences started becoming accepting of the fact that science can be done through AI. I can see there's a question by Duria.
Yeah, I also had this question. So this is from your previous section where you
Hmm.
were talking about MCP
Yeah,
and privacy preserving.
yeah,
So Durya wants to know how MCP addresses the privacy and security issue that is a big topic when it comes to using AI. Would love to hear a little bit about that.
yeah. Thanks for the question. Yeah, so MCPs now feel like they have been there forever, but in AI terms, but it has been like I would say 3 or 4 months, which is a lot. In AI terms, I think that's like 3 to 4 years. That's how much the field moves forward. So MCPs, because they have the option of executing or working at a totally different physical or server space. So they have full control over what they give back to the LLM or what they give back to the AI model, right? So, for example, one of the MCPs we built um, for some of our pharma clients, like that MCP looks at their data, it lives in their servers, so we don't have access to it, and only gives us the structure of their data that is enough for us to write code for their data. So we don't need to know patient information, we don't need to know what their actual ages are, but we just want to know that okay, you actually have a CSV file that has name, age, disease, etc. But we don't want any identifying information. So that MCP allows them to like set up security such that the server only gives the structure of the data, and that's hard coded. So that part, like we're not trusting any AI with it, it's just pure hard coded structure that we get, and that sort of mitigates that need for the model to look at the data, because that is one thing they were really uncomfortable with. They didn't want, say, GPT to train on their proprietary data or Claude to train on their proprietary data. And so that's just one of the examples that we've like how we've used MCPs to ensure that like privacy is preserved wherever it's needed. But like people are coming up with like more sophisticated ways of doing this. Um, but right now, MCPs are working pretty well, if that answers your question.
I just want to quickly add that actually it's a testament to what Vinayak was saying before, how quickly things move in the AI world. But MCP protocol was actually released almost exactly a year ago. And to
Yeah.
commemorate that, there was an MCP night at MIT like 3 or 4 days ago. Yeah, so but things just move so fast. In the beginning, no one paid attention, and then when people realized its potential, everyone was really into it. And yeah, things have come a long way, even in this short span of 1 year. So that just goes to show what Vinayak was saying. Things move really, really fast in the AI world.
Yeah.
Yeah, exactly. So I even so as you said, right, it came out 1 year ago. So I remember reading about it then, but until say 6 months ago or 4 months ago, it hadn't blown up like the way it has, right? And obviously that also is because of like a lot of company politics as well. Because Anthropic created it, OpenAI will not embrace it, but now OpenAI has no option but to embrace it because everybody else has, and like but even then, it feels like in 1 year so much has happened, and like it's at least good to have some standardization in terms of like developers who are working with this, that okay, that means that if I make an MCP, at least everybody can use it, which is a good thing. So any more questions on any of these things?
Yeah. So this is Duria.
Yeah.
What I just kind of wanted to get clarified in my head is thanks actually for explaining how MCP did address the privacy issue. I hadn't exactly looked at it this way. So the difference is RAG still runs on the same, is connected to where the LLM is running. Is that it?
Yes.
And therefore has visibility to all the data. Whereas with MCP, you can just give a very defined, you don't need to know the details of the data. You may just need to know some semantics about it.
Yeah. So with MCP, I would say that's doable. As in, if you just want the semantics, or like that's an example of what it can do, right? So say if you just want like, for example, when you're doing RAG, it looks at the whole data. What if RAG is behind an MCP? So that is possible.
Okay.
Like some people have done it. So it's like, so you can think of MCP as this wall between what you want to show and what you don't want to show. So everything behind the MCP is isolated from what's interacting with the MCP until and unless the MCP wants to expose it itself.
Okay,
Yeah.
got it.
Yeah, that's a very interesting perspective, because the way I imagined MCP was always like this vehicle that allows you to also perform actions with generative AI,
Right.
because until then it just gives you a plan to do A, B, C, but with MCP you can do more than that. You can actually execute some of your ideas. But to think of it as a wall, like a privacy preserving wall, is a very interesting perspective. So thanks for sharing that example as well with your client.
Yeah. So as you said, right, MCP is obviously like the primary use still is actually giving a list of tools so that it can do much more than just like give out text for something or plan for something. Right? That's still one of the major uses. It's just that you can make those tools privacy preserving now. So because we use that a lot, we are working in the biomedical space as well. So that's why I thought like we had to think harder about how to do the privacy bit, but we can talk more about it towards the end as well. I can
also could you
try
address,
to.
could you address the protocol aspect? Because it's not just a firewall, it's also a protocol that's standardizing. So if you can say some more about, what's the protocol, how standard is it, and how easy it is to implement.
Yeah, so I would say right now it's probably the only protocol that most of the people use to serve tools, because typically you want to serve multiple tools. So that means, like for example, Zomato actually in India just came out with the MCP. Say if someone wants to write like a generative AI program to order food every day at 9 a.m. So they can actually use the Zomato MCP to do that. And why that has become this general? So Anthropic came up with it. Initially, it wasn't general. Like people would, so tool support was there across all the LLMs, the big LLMs, the big players. But only Anthropic was using MCP. Gemini uh, started accepting it. And now finally OpenAI has started accepting it. So all the connectors that you see on your chat GPT, they actually use MCP. So it's easy to set up. So you can either set it up locally through a local host server. So at the end of the day, it's a server, right? So that you have to set up either locally or remotely. Because it's a server protocol, you can, like it's possible to have it anywhere in the world on HTTPS, or you can have it locally on localhost. So that gives you some flexibility. And like it's very easy to set up. Like I do not have a software engineering background, but I was able to set it up because the tools for developing around it have become very easy, and especially with vibe coding, like all of the boilerplate stuff becomes easier as well.
Okay, thanks.
Yeah, if you want to learn more about vibe coding, we do have a workshop coming up next month. So feel free to reach out to me if you want more details.
Okay, so I will move ahead with this part of the presentation. So we've already talked about how AI has been taking over scientific discovery. Let's think about what it means to do scientific discovery, right? I think a, a lot of work that's needed to make AI systems is also just introspection on how humans were doing all of these things in the first place. Uh, because at least that's my philosophy. Like, we shouldn't be building AI to reinvent the wheel. We should be making AI to like automate parts of existing workflows or think of newer workflows only if needed, because there's a lot of optimization that has already went into, or like say task specialization that has went into um, that went into like thinking about human workflows. Say how scientific discovery happened, right? You create hypotheses, you design experiments to test the hypotheses, you test that experiment on data, you actually carry out the experiment on data, and that gives you some insights. Sometimes you're able to prove hypotheses, disprove hypotheses. Sometimes there's just some weight added on one hypothesis with respect to other. Like, this has how science has been going on um, traditionally. Then the data-driven approach came to be, where you collect a lot of data, you try to look for patterns. So this is like, you can say the AlphaFold style, or like the black box style of doing science, where your model is the scientist in some way, where it looks at a lot of data, mines the pattern that humans used to mine earlier, makes internal statistical models, and then gives you correlations and insights that humans have to sort of contextualize, think about, make sure that they make sense. They're not like that the models they're training are not overfitting on data, et cetera, et cetera. Like basically data first way of doing science. That you can say from 2015 onwards, it has been happening a lot. Like, this is how a lot of scientific projects are actually going on. And then this is the emerging approach. This is the approach that now, with something that actually we've been calling vibe research, has been happening. I know it's a the word vibe has been overused too many times in the field now, but yeah, but it's a good way to explain what's happening, where there's data and there's some intuition. Because as scientists, we also come with some intuition from our previous knowledge, or sometimes actually nowadays, just because of our search that we've done through AI, that like we develop some intuition. We read a lot of like outputs from AI that gives us some intuition. Then we have some prompts, like what we actually want to accomplish with the data. So there'll be some pattern mining and hypothesis generation done through AI. Insights would be generated. And the biggest part is the insights would pipe back to the starting point very fast. So instead of the data-driven approach that takes, say, months to materialize, because you have to build each of those modules, like the pattern miner, the statistical model, thinking about the insights. Now this whole thing, because it happens faster, like your intuition keeps on improving, and you're able to carry out multiple rounds of science much quicker, and hence novel discoveries come out faster. So just to give you an idea of how one can do that with agentic AI, I've explained what agentic AI is like uh, earlier, but now to give you a visual understanding of what I mean by that and why I'm talking about that in this context, is think of this as the scientist, the agent core. And think of this as, say, your PI, or the professor you're doing the research with, or say some supervisor you're working with. So the supervisor gives you a task, the agent core a task. You have some memory, because like you have read papers, you have done some research, you have some intuition, you have some memory, you have access to some online information. You have an internal planning module, your prefrontal cortex in your brain, or like many parts of your brain that help you in executing the plan as well. And you have tools, like you have hands, you have agency, right? So it's the same thing. Now the AI agent is acting like that PhD student or that low-level researcher that is getting feedback as well as instructions from the user which you can think of as like the lab manager, the professor in charge of a project, or the senior author on a project. And they're just trying to use the tools, the modules that they have to the best of their ability to actually carry out research. So this approach has worked really well in like startups like Harvey, which have sort of automated a lot of like legal documentation, have been helping a lot of lawyers all across the US. You should definitely check out Harvey. And also Cursor, which is very big with vibe coding. Again, like there's a vibe coding workshop next month that you guys can attend, where actually the same thing happens. You go to Cursor, you say, please build me a website, a personal web page, and you give some instructions. It has access to all of these modules, and it would actually, Cursor would give you choice for which agent you want to use. Say you want to use Claude Sonnet 4.5, and then it will access the memory that it has about your code or about your previous behavior or information online. It plans what it needs to do to actually make that website, and it has multiple tools at its disposal. For example, like looking at the final website to make sure that everything works well, right? That actually makes sure that the whole process is done. So think of vibe research as the science way of doing this vibe coding bit. So here's the agentic AI scientist that we built, which is called Cadence, right? So for Cadence, one of the main things has been, like if you look at this diagram, I know it can be an intimidating diagram, but the modules are what humans have been doing for a long time. There's no, I won't say there's like any novelty in the way we are doing things, right? Because there's a literature reviewer, there's a research planner, there's a coder and analyst, and there's a writer and summarizer. So this is exactly how humans also do research, right? Like you look at previous literature, you identify some like open gaps in the field. Like you see, okay, given that I have this data, I should be able to tackle this set of competing hypotheses on the field. Then you plan how to do that. The research planner would do that. Then you have the coder and analyst that will actually write up code to try to execute the research plan, if it's a computational plan. And the writer and summarizer sort of contextualizes all that you have done in previous literature, which would now be reviewed like humans review manuscripts, and then feed back to the literature reviewer saying, you should go back and actually look for more papers in this because it looks like what we have done is not novel enough. And then this cycle continues before we get something that's useful. Yes, Richard.
Yeah. One of the questions that I have here about using AI for scientific discovery, one of the limitations I've seen is that AI, even despite, the really large context windows that models have today, they tend to forget some of the more important details in the context that you provide. Like, for example, in your literature reviewer, if I were to feed it, say, 2 or 3 papers, I wouldn't feel very confident that it picked out on the most important items. But whereas as humans, we're able to quickly identify and store all that context pretty easily. So how do you work on that?
Yeah, that's a good question. That's actually a great question because that's one of the main, you can say, practical issues that come to be when, like, theoretically this makes sense, right? But practically, that's one of the biggest issues, which is something that actually, like agentic AI actually helps a lot in, because one model, even though it has a very big context, is not able to look at, say, 50 instructions parallelly. It's not able to actually follow all of them. Every model has their like limitation as to how much they can do at once. So there's one way that recently we've been using, which actually came out last month, which is skills in Anthropic, which has been working very well for us. Because what happens is, instead of loading the context with a lot of instructions, it loads the context of the model with the instruction that's needed right now, and then removes it, and then moves it to the next instruction. So and individually, these are all skills. For example, so in the literature review, so actually, like, I'll be honest, so we have about 10 agents that make the literature review. So it's not just one agent. So these are like big systems, right? So, but the literature reviewer, for example, the agent that is doing, so there'll be 10 agents, so there'll be like 2 agents doing background research. Then there'll be a writing agent that again has research capabilities. So you first look at all the papers you need and what they mean. But then while writing, there's another agent that can rethink that. So there are many passes. So even though like a lot of information would be left, um, which humans might want to add, uh, but when you do multiple passes like these, there's a higher chance that you'll get what you need. Um, so we call this actually hierarchical multi-step reasoning, because like they cannot reason about everything, but if you make them like reason about information hierarchically, like first, there's a 3 main verticals in which I have to do the research, and then within each vertical, now there are more agents that are doing like 5 research subtopics each. Like that usually works pretty well.
Okay, so making the process more iterative with agents really helps capture most of the information that you'd get from the literature reviews, enabling you to really perform like a deep research.
Yes, exactly. And the good thing is, because this whole process takes less time, you can now, even if your literature review is imperfect, because you'll get to do it so many times, eventually it will actually become closer to what a human might have done with like some amount of time that they would have had, right? And like this whole AI scientist will get access to what data it has or what the user wants with the thing, because at every step, actually, there's human in the loop. So after the literature review, so you can choose to actually just edit it or like give more, because there are like loops within the systems themselves where like the system can reason within itself, right? So you can actually just work on the literature review initially. It's not needed that once a literature review is generated, you have to go to the planning stage. You can iterate there as well with the agent. You can be like, you looked at 40 citations, but you haven't looked at any papers by Josh Tannenbaum. Please look at more papers by Josh Tannenbaum and make sure you consider like the latest paper from that lab. And it'll do its thing and like edit it accordingly. So that iterative process, still, I would say human in the loop is a very critical aspect of all of this. And as you said, right, like you have data and user input on one end, you have LLMs, tools, and databases on the other end that are continuously at the disposal of the AI scientist to like make queries. So the scientist actually decides which LLMs it wants to work with. It just gets access to a bunch of them. And some LLMs are good at something, some LLMs are good at other things. So we just optimize for like letting the scientist choose what to use for what. And then the main idea is obviously the number of iterations you do through this whole process here that can lead to novel discoveries, not because novel discoveries are like something I would say totally out of reach and it's like crazy to do it. I think most of novel discoveries are right now are just blind spots in human research that could have happened if, say, the best coder would have worked with the best biologist, for example, or even like an average coder would have worked with the average chemist. But that doesn't happen because interdisciplinary research hasn't, like, there's no perfect interdisciplinary research. Let's just put it that way. But with AI scientists, like, that's possible because your scientist can be an expert in both math and chemistry and CS and biology to like get a low hanging fruit only if the researchers from those fields would have come together on that data set. So, and the proof is in the pudding. Like once we do this like human inspired thing of like just making sure each of those individual modules are somewhat mimicking what humans do, we got like really good results on Bixbench, which is a benchmark for bioinformatic tasks. Like we were state of the art on that. Actually, we still are. And even humanities last exam. So we tested it on the bioclinical subset of humanities last exam, which is also a computational benchmark. It's a very hard benchmark that like all of the big LLMs test it on. Actually, we're no longer state of the art on the bio subset because Kimi K2 just yesterday there was a model released in China which is open source that has performed 50% on this. I think on bio it will be like 45%. So like every day something happens. This figure is now obsolete. When we came out with this, like we were doing the best on this. So it's basically a very tricky set of questions, multiple choice questions. You can actually think of it like JE, but like with like a lot of gotchas, and like models were really bad at doing it because they were thinking. So they always have this issue, right? They think as very good mean reasoners, as in like average reasoners. They'll like average out their knowledge base. But like for edge cases, they might not work as well because edge cases are underrepresented in their training. So a lot of times edge cases don't work as well. But like we tried to like work on that and like make sure that the edge cases are also represented better, because for science that's a very important point, because a lot of science actually happens at the edge cases and not at the like average cases. So what's the main source? Mainly it's do not recreate the wheel. This wheel that Cadence does of like going from question to report and back to question to hypothesis to analysis, this is an existing wheel. It's just that we're doing it with AI as different components. Still, there's a human checkpoint. Still, human has the ability to get in anywhere it wants to. Why? Because like we trust the existing processes to some extent, and we wanted AI to mimic parts of these well-established workflows, because this also helps seamless integration of AI in existing workflows. Because one thing we found that like people don't want to entirely change the way they work, right? Like they already have a set way of working. They trust the process. So the best thing we could have done is also trusted the process and made sure that they understand this process. So how AI is doing it, so that if you want to get into the hypothesis bit where the plan was generated, now you want to just edit the plan. Like you should be able to do it. It shouldn't be behind closed doors where you just put in the question and wait for 2 days and then you'll get some answer. I think humans do want to be involved with any scientific discovery that they are being part of. And so to give them this opportunity, the process should be easily palatable as well. And obviously, I think for me, the main source is actually integrating my learnings from human cognition that helped me optimize resources and perform seemingly impossible tasks. Because like the brain does it, right? And like we used to talk about it a lot when I was still in grad school. And like, for example, hierarchical reasoning. Brain also has limited compute, limited context, but it tries to like reason hierarchically to make sure it extracts the most out of a situation. Like, for example, if you have to go to Costco in Boston from San Francisco, you'll first think of going to Boston. You'll not try to like navigate to straight to that point in Google Maps, right? Like you'll first go to Boston, first city level, then within city region level, and then within region you'll go to the right street, right? So humans actually think hierarchically, and we try to build that in here as well. And in the interest of time, I'll like skim over this slide. This is just, I would say this is more of a sales slide where like we show that it's like from 3 to 6 months, we have condensed the whole research cycle to 2 to 8 hours. And instead of 3 to 5 people, you need now one scientist, a good scientist, who wants to be a PI to say 5 Cadence grad students. And those 5 Cadence grad students keep doing things that the PI says. So obviously the scientist becomes more important, like their skills become more and more important now, because they can no longer say they're working on something for 2 months, just setting up an experiment. Their experiments will be set up by AI. They just need to make sure that they're doing the right thing, as in like they're giving the right instructions, evaluating it correctly, etc. Yeah, and just to illustrate why this is important. So obviously there's school and all, but why is this important? Because there's a growing gap and what we can analyze as humans, what we can derive insights from, and how and the pace at which data is generating, especially in biomedical research, which like we started with initially. Because the issue is data sets are increasing, right? There are also past data sets from times where we didn't have computational tools. We have a lot of biomedical data, but the human capacity does not increase exponentially in the same way, right? Computational tools keep coming up, new computational tools come up, old data is still lying there. How much, like we need a lot of human capacity to actually churn out all of that previous data, new data, keep finding insights. That's why we have like a lot of like data science teams, a lot of scientists within companies, within academia, because the data exists, but like there's just so much insight lying within the data that like we're still not able to tap into it. So this is where actually our research with David Sinclair came to be, where actually we used Cadence to invent a highly accurate and uncertainty-aware transcriptomic aging clock. The full the preprint is available on bioRxiv. We've submitted it to places. Fingers crossed. Hopefully, it gets through. The idea being like how we did this. So there was large scale transcriptomic data that was untapped. So it was just sitting there, 600,000 samples. It's actually called R-test. So transcriptomic data, by the way, for people who don't know, is like RNA sequencing data. So from humans and mice, this is like if you do RNA sequencing, you get some gene counts. And this is that data that was just online. Actually, ICANN School of Medicine had put it up, and it just lied there. Then we did 2 iterations of science through Cadence, tried to extract information for like predicting age. We're like, can we make a age prediction model? So we try to give prompts related to that. Then we contact David Sinclair, who actually gets convinced of the novel findings. By the way, for people who don't know David Sinclair, one of the most famous people in longevity space, has shown up on Joe Rogan, has like more than or like about 1 million Twitter followers. Like he's the guy you would look up to if you want to like live forever. So a lot of rich billionaires pamper him a lot. He has a lot of funding to make sure that he increases the lifespan of human beings in general. So like he was actually very convinced of the findings. We thought the findings were not as novel because we thought, well, this was easy. Like anyone should have been able to do this, because coming from an ML standpoint, machine learning standpoint, we didn't do anything novel, like existing models that we knew existed ML wise, but on novel data sets that we didn't know existed. But we were able to do that in like a matter of days. Then he said, okay, I like the findings, but I want to improve them. So we do 3 more iterations of science through Cadence, like make sure we are situating the research correctly and everything. And then finally, like he reached out to the editor of Nature to like agree to put to like expedited review, because the output, like once we actually did multiple rounds of Cadence, we realized, wait, actually the field doesn't know this. Because we didn't know what the field knew and what the field didn't know, because we didn't have that background. Specifically, I didn't have that background. I was not from the transcriptomic sciences, RNA sequencing, or like biology background in general. So we trusted David Sinclair on this. And then like, just to give you an idea of what it was, like we're just initially testing basic machine learning models like XGBoost, light GBM, linear regression, ridge regression, elastic networks. And then the Cadence system actually came out with a mixture of experts idea, where it said, looks like the aging in different parts of our lifespan happen differently. So a single model shouldn't be used for different age ranges. So it started using different models for different age ranges. And that gave us a much better age predictor. But then as human scientists, we were like, this is good, but then we need to know what range someone falls into. Like this probably isn't the like most, this isn't the exact thing we wanted. Then what AI found, like this actually, like we call this the staircase of aging. This actually shows the genes that are implicated in aging at different human ages. And we found that that continuously changes. So this was the novelty. So people used to think, okay, aging is a unilateral thing. Like you try to control some biological pathway, like you'll age slower or you'll age faster. But seems like it continuously changes how you age. Like as a child, your aging is more like, for example, about development. It's not about withering away of your skin. Like that's not part of your aging process as a child. There were theoretical hypotheses for this, but there was no like practical or like computational substantiation for this. So this is the first sort of proof that your aging actually continuously changes. It does not have like step changes. It's like a continuous change on like which genes are important or which biological pathways are important. So using this, actually Cadence built a novel clock where it said, okay, if the aging actually changes continuously, why don't I create one model for every age range, like with a step of 1 year each? So 1 to 31, 2 to 32, 3 to 33. Create all of these experts, make them predict age, and then look for consensus. Because if like they have a consensus on some age, or like a large number of those models have consensus or something, like that prediction should be trusted more than other predictions. And that actually ended up working pretty well. So now this is like you've given just say a blood sample of somebody, and you get to know how old they're biologically. So this is the biological age, not like their chronological age. Um, and this was done like through Cadence. And like this was the main thing. Like this was the first model that could do like uncertainty aware prediction, because this model also knew whether it could predict or whether it could not predict. So it would just decline to predict. Basically, there'll be no consensus between experts if any sample was hard to predict age for. I think we are low on time, so I'll just skim over this. So what we're doing now, we're working with companies to like automate part of their scientific workflows and also bioinformatic workflows, trying to white label this to other like scientific computing companies, so that like this can be a functionality within like other software, so that we can penetrate to scientists. Instead of bringing them to our platform, we can go to the platforms that they already use so that they can use these functionalities. And we are also doing a lot of open source contributions. So you guys can check out Claude Scientific Skills or Claude Scientific Writer that we've recently released that bring these capabilities to your desktop for free. So because we also want scientists, because scientists, let's face it, not the richest of the lot. Like we don't want to put a huge cost barrier for them to enter this space and use these tools. And yeah, these, I will skim over this, just showing you some outputs from the scientific writer, like the treatment plan, like you can like generate treatment plans, full papers, like papers here with like real references. Yeah, and by the way, all the figures that you see, that you saw, like all of these, like these are all outputs from our agentic system. So yeah, so in general, we've come a long way. So in summary, we talked about how agentic AI works, how we developed Cadence, what we found with David Sinclair in longevity research, and like how we are now also doing these open source projects that help like all scientists get a taste of what doing science with AI feels like. Thank you.
Thank you so much, Vinayak. That was a fantastic talk. Love to learn everything that you were up to at Cadence, and love to hear more about how you're accelerating scientific discovery with tools that many of us are already using at a small level, but taking it to a scientific discovery capabilities is truly fantastic. We are over time, but if people have questions and are willing to hang out for a few more minutes, we can definitely do that. So feel free to raise your hand, and I can call your name out.
Alternatively, Vinayak, if you can put an email address or some way for people to connect with you if they have questions afterwards, that would be very helpful too.
Yeah, actually, so my email address, I'll just put it in chat. Right?
Yeah, I also want to inform those who are still here that we will be sharing the slides in a follow-up email through Eventbrite, so you can have a look at your own time, and also feel free to reach out to Vinayak on his email address to discuss with him further. With that, yeah, thank you so much, Vinayak, again for joining us from across the coast. Uh, Amazing talk. There is one hand, uh,
Yeah.
Vijay.
Yeah, hi. So mine is a more general interest question. I mean, you've focused more on biological sciences and such. I'm retired now, so just want to look at things in general at a much lower level. So there's publicly available data like census data, there's like police reports. Is it possible to use like cadence engines to, come up with research based on census data? And actually, if you don't know what you're looking for, will it help you? Will it guide you? What are the possibilities, basically, what I'm asking?
Yeah, actually, that's a very good question, because I think the sky is the limit, because we also don't know the extent to which it can help. Till now, it has been helping us a lot. For example, like you said, census data, right? So I know. So when we did a limited release to some people in India, um, there has been a lot of research. So people did lots of crazy research as well, right? So they also did research on why DMart is crowded during a particular time. And like people actually wrote full research papers on that using our system. Like because there was like some data available through Google on like when the footfall is more in a particular store. So I'm guessing that there are many unanswered questions, or like unasked questions actually, in like rich data sets like census, or say rainfall, and how different things correlate with each other, like to look for causations, that I feel like only if like good researchers had the bandwidth and had the interest to look at all of that data, they would be able to accomplish. But with cadence, I think we would be at least able to get like 85 to 90% there. So I'm pretty sure like if you want access to the system through our open source repo, obviously it's already available, and it will be great to see and work with you on data sets like that.
So do you have an open forum, or do you have a place where people can ask these questions or see what other people are doing, get some examples?
Yes, so I will actually share a link to the Slack community we actually just recently formed. So we created a Slack community for this entire reason, because like people wanted to talk to other people using the system on what they're using to get ideas, because this is a new space, right? It's like uh, uh, it's good to look at what other people are also doing. So I can share that with the team, and like with the slides, actually that link will also go through.
Yeah, the first question to ask is, am I crazy thinking like this? Or is this thing possible? Something like that is a good type of questions to ask. Yeah.
I think you're like thinking like, I think that's a great idea, because one of my initial motivations was that I wanted to actually enable science for developing countries as well. I feel like one of the main reasons why a lot of data sets from developing countries like say India or Bangladesh or countries in Africa get totally ignored is because there are researchers who are interested in working with them, but there's no money in working with them, or like there's like no bandwidth that they don't have the computational resources, or sometimes even the language to put the research together in a way that's like palatable to the Western audience. And like these tools can actually help that. And especially with these kind of data sets that are largely untapped, like there's so much data that say the census of different countries like just puts forward, that just goes untapped. And even from previous years, like we have so much data just lying there. We have a big data problem, like where obviously any amount of data is good data for creating these models. But to do science, I feel we are still lagging very much behind in like doing good science with a lot of data that's publicly out there. So I really appreciate you thinking in this direction. I think it's a good direction.
Thanks. Do you offer any resources? See, I'm teaching a class to some Indian students over Zoom. Do you offer any student type resources that they can access, like a website, to use some of the computational power that you might have for students?
So we are going to release that soon. So we're working on that like self-hosted version, where like we'll be able to share it with like people so that they can actually do that. But I'll try to put together a list of resources with the slides, like once we share the slides.
Yeah, we can put together the resources that Vinayak's talking about and share that in the follow-up email. Since I don't see any more questions, once again, Vinayak, thank you so much for your time. This was a very informative talk. Loved having you here. Yeah, and thank you so much, everyone, for joining us and staying a little bit over time. We're hoping to see you all in the upcoming sessions that ITECME is going to be hosting. So yeah, stay tuned. Thank you so much.
Thanks for organizing this, and thanks, Vinay.
Yeah, thank you.
Gladly.
welcome.
Thank you so much.
Thanks everyone for coming.
Yeah. Thank you.
Have a good
Thank you.
weekend. Bye.
You too. Thank you, guys. Thank you.
Thanks, Vinayak.
Thank you.